Hello pre-calc students, today we're doing a lesson on ellipses. The definition of ellipse. Ellipse is a set of all points x, y in a plane whose distance from two fixed points in the plane have a constant sum. The fixed points are the foci, plural focus, of the ellipse, and the line through the foci is the focal axis. The point on the focal axis midway between the foci is the center. The points where the ellipse intersects its axis are the vertices of the ellipse. The center of an ellipse is the point on the focal axis midway between the foci. The foci, plural of focus, are the fixed points equidistant from the center. And located on the focal axis. Focal axis is called the major axis. The points where the ellipse intersects its axis are called the vertices. A line segment with endpoints on the ellipse are also called chords. All right. So let's so we'll do the next part, the visual vocabulary, verbal vocabulary, and next part, the visual vocabulary when we move down, okay? So, first of all, we have a vertex here. This is a vertex. And we have vertexes right here. And a vertex right here. And we have a center, and then we have a major axis. So this right here is the major axis. And it's a major axis because it's the longest version, and the foci lie on here. This is the major axis. All right, and we have foci on the major axis. So we have a focus here. So if our foci on the major axis, we have individual foci. So we have a focus here. And we also have a focus here. All right, we also have a vertical line. This is called the minor axis, okay? And this would be called the B semi-minor axis. B is equal to the semi-minor axis. So B is the semi-minor axis. All right. I'm looking at the major axis. The major axis is going to have this length will be A. So this length is A, which means that the full length of the major axis is 2A. Okay? So get this down. This is the first part of verbal and visual vocabulary. So pause it. I'm going to clear annotations. After chords, we have a major axis. So we call the chord lying on the focal axis, so the major axis, and the chord through the center perpendicular to the focal axis is the minor axis. The major axis length is 2A. The number A is the semi-major axis. The length of the minor axis is 2B. The number B is the semi-minor axis. So we had a horizontal ellipse first. Now let's label a vertical ellipse. So again, we have some vertexes. That's a vertex. This is a vertex. We also have our major axis with a vertex, okay? We have this point. Now, because it's a vertical ellipse, we have foci on the major axis, which is now vertical, okay? And remember this length right here, half of the major axis is the semi-major axis. And that is equal to A. So the semi-major axis, so the major axis is equal to 2A. This whole thing is equal to 2A. The minor axis is equal to 2B. And then the semi-major axis equals A. And the semi-minor axis equals B. Also, as a heads up, the distance between the focus and the vertex is equal to C. This is equal to C. All right. So hopefully that will help with your conceptualization. Let's keep moving forward. Also pause at any time if you need to get extra notes down. Our Pythagorean relations. So we can use right triangles to figure out our Pythagorean relations on the ellipse. And we can also use that to write an ellipse as an equation. Remember, for our equation, the major axis is always going to be longer than the minor axis. So in the equation, A is greater than B. We have an ellipse with a center 0, 0. Okay? Actually, let me look down at your paper. Let's go to our equation. When A is greater than B, our ellipse has the following property. X squared over A squared plus Y squared over B squared is going to be equal to 1. Alright, so this is going to, and if you think about it, this is going to be when X is over A squared. This is going to be a horizontal ellipse. Alright. A vertical ellipse is going to be when the larger denominator is over the y term. And that's going to have the equation x squared over b squared plus y squared over a squared is equal to 1. The focal axis is the x-axis. And here the focal axis is the y-axis. The foci will be at plus or minus c, 0. And here it will be 0 plus or minus c. The vertices will be at plus or minus a, 0. And here they will be at 0 plus or minus a. The semi-major axis will be equal to a in both cases, b in both cases, and you have the same Pythagorean. An ellipse has the Pythagorean relation a squared is equal to b squared plus c squared. Alright, so let's look at graphing some basic ellipses. So these are basic ellipses because they have a center at 0, 0. Alright, we have x squared plus y squared, and the x squared is over 25, y squared is over 9, that's equal to 1. Well, here, a is equal to 5, b is equal to 3, and that's because 25, that equals a squared, 9 is equal to b squared, and then c, if we have the Pythagorean relation, then we know that with our Pythagorean relation, the a squared equals b squared plus c squared. So if a squared is equal to b squared plus c squared, and 25 equals a squared and 9 is equal to b squared, then 25 is equal to 9 plus c squared. Do some math, and c squared is equal to 16. If c squared equals 16, take the square root of each side. C is equal to 4. Our major axis in this case, notice, is going to be the x-axis. And the reason why the major axis is the x-axis, that's because our larger number is over the x term, okay? So because our larger number is over the x term, our major axis is the x-axis. Here, this is a basic ellipse, so there's no modification to the x or the y. So the center is at 0, 0. Our major vertices, okay? Because this is on the x-axis, we're going to be looking at our going near center, moving in a direction in each place. So our major vertices are going to be at -5, 0, and 5, 0. Our minor vertices will be at 0, -3, and 0, 3. Our foci, now that we know C, are going to be at -4, 0. Remember, this is on the foci lies on the major axis, and 4, 0. All right, so our foci will be right here. This will be F1 and F2. All right, and we can draw our ellipse right here. So, and remember, this is the center right here. Now, so the main point is that if we can know the denominators of the ellipse, we can use our Pythagorean relations to find A, B, and C. And from that point, if we know the major axis, we can plot points to create the ellipse. All right, so that's example 1. Let's go to example 2. Finding an equation of an ellipse. Find the equation in standard form for an ellipse whose foci are 0, 3, and 0, -3, with a major axis length of 10. So right away, we know that the foci are between 0, 3, and 0, -3. So the vertex, so let's draw our foci. We have 0, 3. That's a focus. We can call that F1. And we have a focus at 0, -3. F2. Now, the center is in between the two focus, so we know that the center is at 0, 0. And we know that because 0, 0 is the spot in between the two foci. We also know at this point, because the foci are between 0, 3 and 0, negative 3, the foci are moving vertically, so our major axis is vertical, which is the y-axis. Y-axis is going up and down. Our major vertices, now we're going to have to figure our major vertices based on, we know that our major axis is the y-axis, and if our major axis length is 10, the major axis is equal to 2a. So 10 is equal to 2a. So we can find a by dividing each side by 2. 10 divided by 2 is 5, which means a is equal to 5. All right, so we have a major axis length of 5. And if our a is equal to 5, and our center is at 0, 0, we know our major vertices are going to be at 0, 5, and 0, negative 5. And that would make sense because this is the major axis. We go to 5, we have major axis 0, 5, and 0, negative 5. Those are some vertices. And from that information, we can, our foci are given to us at 0, 3, 0, negative 3. Also, our C, the distance between the focus and the vertex is 3, so C is equal to 3. And at this point, we can find B using our Pythagorean relation. So we know that with our Pythagorean relation, A squared is equal to B squared plus C squared. So A squared is equal to 25. B squared plus C squared. We don't know B squared, but we do know that C squared is equal to 9. So 25 is equal to B squared plus 9. B squared is equal to 16. B is equal to 4. All right. And now we have our equation. We have x squared plus y squared is equal to 1, okay? And we have denominators. This is a major axis, so this means this is going to, a squared is going to go, which is the larger term, is going to go under our y term. So it'll be over 25, because that's a squared. And b squared is going to go under our x term, because that is the minor axis. And b squared is going to be equal to 16. So that is the equation of the focus. Now B is located at, now the B is equal to 4. I know our minor vertices are going to be 4, 0. And negative 4, 0. All right, and now that we've drawn our vertices, we have our vertical ellipse. So I'm not good at drawing here, but that's the ellipse. All right, just note that so this is labeled wrong in the answer key that I posted. It would be 4, 0, not 0, 4. So 4, 0, negative 4, 0. So that's example 2. A more general form that you should know for ellipse with a center HK. So now you could have any center HK. So once again, Let's scroll down to get this information down. The top is with a horizontal. The left is going to have a horizontal ellipse. The right is going to have a vertical ellipse. This will be horizontal. And this will be vertical. Our equations. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. Here we will have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. The center is going to be HK. Here the center is going to be HK. The focal axis is going to be y equals k. The focal axis here is going to be x equals h. The foci is going to be h plus or minus c, k. H plus or minus c, k. And here it'll be h, comma, k plus or minus c. The vertices will be at h plus or minus a, k. This is for horizontal, or h, comma, k plus or minus a, or a, remember, is the semi-major axis length. C is the focal length. All right, semi-major axis, A is A for both horizontal and vertical. Semi-minor is B for both horizontal and vertical. Pythagorean relations is still A squared is equal to B squared plus C squared. A squared is equal to B squared plus C squared. Okay, so again, you can pause it, but I'm going to clear annotations and move on. All right, finding the vertices and the foci. For example 3, we have 9 times x plus 3 squared plus 4 times y plus 2 squared is equal to 36. So we have A as 3, B as 2, and C as a square root of 5, which is equal to 2.24. All right, let's break down how we get these numbers, all right? First of all, our center is at -3, -2. So that's because we just switched the signs of the terms x plus 3, so the x coordinate is going to be -3, y plus 2, the x coordinate is going to be -2. So we're switching the signs for the -3 and the -2. So that's the center. We also can divide each side. Thing is, with our standard form, what we have to do is we need to have 1 in our equation, okay? So we're going to have 1 in our equation. We need to divide each side by 36. Because we need to have a 1 on the right side of the equation. So we divide this side by 36, this side by 36. And 9 divided by 36 is going to simplify to 1/4. So 9 over 36 will simplify to 1/4. And x plus 3 times 1/4 can be written as x plus 3 squared over 4. 4 divided by 36 is equal to 1/9. So y minus 2 squared times 1/9 is equal to y plus 2 squared over 9. And that's equal to 1. So this gives us our standard equation. And from the standard equation, we've come up with a bunch of things. We've already come up with the center. And we found A because A is the longer of the two, so it's going to be the larger of the two denominators. So that 9 is associated with the A. And A is equal to the square 36, remember, that 9, that's equal to A squared. That 4 is equal to B squared. So not 3 is equal to the square root of 9. Square root of 9. And that 2 is equal to square root of 4. All right. The C is going to be equal to the square root of 5, which is equal to 2.24. Now, how do we find C? We'll use our Pythagorean relation again, okay? A squared equals B squared plus C squared. So 9 is equal to B squared is 4 plus C squared, which means C squared is equal to 5. If C squared is equal to 5, then C is equal to the square root of 5. So C is equal to the square root of 5, and that's why C, square root of 5, right here, 2.24. So from our A equation and our B equation, let's find the center. The center is at -3, -2. So that's an approximation of the center. All right. The major axis is going to be, remember, this is vertical, okay? So our major axis is going to be the y-axis, and that's because the 9 is under the y term. So our major axis will be the y-axis. Which our major vertices are going to be, they're going to have an x value is going to be locked in at -3. So the x values of our major vertices will be locked in at -3. And we're going to have to take our -2 and add and subtract a. So those major vertices will be -2 plus 3 and -2 minus 3. So the major vertices will be -3 and 1 and -3 and -5. And we get that 1 and that 5 by doing -2 plus 3. That's going to be 1, and -2 minus 3. That's going to be equal to -5. So that's the scratch work on the left, okay? The minor vertices. On the minor vertices, now the y-coordinate of the center stays fixed. So we'll have that -2 all in place. And now we're saying at -3, we're going to be adding 2 to each side. So -3 plus 2 is going to be -1. And -3 minus 2 is going to be -5. So let's draw our major vertices, okay? Our major vertices are at -3, +1. And our minor vertices are at -3, -5. Our minor vertices are at -2, 1, My fault. Neg, because we have negative 3 plus 2 is, oh sorry, negative 1, negative 2. Good. So we have negative 1, negative 2. Sorry, negative 1, negative 2, and negative 5, negative 2. Okay. And we can draw the whole ellipse now at right here. This is the ellipse. Last part is the foci. The foci land on the major axis. So because the major axis is the y-axis, we're going to be moving on the y-axis. So we're going to still be locked in at negative 3 as our x-coordinates. All right. And we're going to be moving plus 2.24. So we can do negative 3 and then negative 2 plus the square root of 5, negative 2 plus the square root of 5, and then negative 3, negative 2 minus the square root of 5. When we have negative 2 minus the square root of 5, we're going to be going up about 2.24 and down about 2.24. So we can put our foci around here. Call that F1 and F2. And so that is the ellipse. You can also try graphing these on Desmos to get an intuitive feel for this. Clearing annotations, you can always pause and go back to the notes. Let's look at the eccentricity. The eccentricity of an ellipse is E is equal to C over A, where A is the semi-major axis, B is the semi-minor axis, and C is the distance from the center of the ellipse to either focus. Prove that the graph of the equation is an ellipse. Find the vertices, foci, and eccentricity. So we have 4x squared plus y squared minus 32 plus 16y plus 24 is equal to 0. So this is going to take some steps and it's going to require completing the square. All right. So my first step is to sort the. Let's just do this color code. Sort the x's, the y's. Okay. With the x's and the y's and get the constant on the other side. All right. So I'm going to have four x squared minus 32x, and I'm going to have to complete the square here, plus y squared plus 16y gonna have to also complete the square, and that's going to be equal to negative 124 plus the two terms I have when I complete the square. So you're going to have to add the term that complete the square for the x term and the term that I complete the square for the y term. All right. My next step, I'm going to have to factor out a 4. When I factor out the 4 and complete the square, I'll have factor out the 4, and then I will have x squared minus 8x, because 32 minus 8, or 32 divided by 4 is 8, And for my completing the square term, that's going to be 16. Here's how I get 16. All right. I know that negative 8 divided by 2 is equal to negative 4. That's step 1. And step 2 is that negative 4 squared is equal to 16. So that's how I complete the square for 16. Now I do my y term. And remember, this is going to be plus y squared plus 16y plus, here, 16 divided by 2 is 8. 8 squared is 64. So we have a 64 right here. Now this is going to be equal to negative 124 plus 16 plus 16 times 4, right, because we still factored that 4, then plus 64. Set a new equals sign, and we can now factor. This term will factor into 4 times x minus 4 squared. It's going to be x, or the term, the variable, and then you're adding whatever was your first term from completing the square. So here, that negative 4 is going to be the same term that we have in completing the square here, and we factored out the 4. Also note that because we added 16 times 4 on the left-hand side, we had to add 16 times 4 on the right-hand side. So remember that 16 is being multiplied by 4. So make it balance, and you have the 16 times 4 right here. Now, the y squared plus 16y, I can show the work here. For this term, when we completed the square, we did 16 divided by 2 equals 8, positive 8, and then 8 squared equals 64. And so that's how we added these 64s. But remember, that's a positive 8. So this will factor into plus y plus 8 squared. This will be y plus 8 squared. And this is going to simplify into 4. And the reason why that's equal to 4 is because 16 times 4 is 64. So that 4 is equal to negative 124 plus 128. That 128 is because 16 times 4 is 64. So that 128 is because 64 plus 64 is going to be equal to 128. So now I have 4x minus 4 squared plus y plus 8 squared is equal to 4. And then what I'm going to have to do is, because the ellipse must have equal to 1 on the right side, I'm going to divide by 4 for each term. 4 divided by 4. So when I divide each side by 4, I'm going to get x minus 4 squared all over 1. 4 divided by 4 is 1. Plus y plus 8 squared. Remember, this whole thing is divided by 4. Divided by 4. And 4 divided by 4 is 1. And it's equal to 1. So I'm doing this so that the right side equals 1. Now, my major vertices, from this equation right here, I have all the information that I need. Okay? The major vertices are going to be, remember, the center is at The center is at going to be at 4, -8. The axis is the y-axis, right? 4 is equal to a squared, so a equals 2. 1 is equal to b squared, so b equals 1, right? And so a squared plus is equal to b squared plus c squared. So 4 is equal to b squared is 1 plus c squared. So c squared is equal to 3, and c is equal to the square root of 3, okay? So that's a, b, and c. That gives us all the information we need to fill out this information right here. Our major vertices are going to be the center plus or minus, with the 4 being fixed and that -8 being plus or minus a. So that's going to be 4, -6 and 4, -10. 4, -6, 4, -10. The minor vertices, once again, now the -8 is fixed. That -8 stays fixed. Now we have 4 plus 1 and 4 minus 1, okay? So we're going to have 5, -8 and 3, -8. The foci are going to be at 4. Remember, the 4 stays fixed. -8 plus the square root of 3. And 4, -8 minus the square root of 3. Then the eccentricity, which is c over a, is going to be square root of 3 over 2, which is approximately equal to 0.866. All right. Here's just a cool food for thought. If c equals a and the eccentricity is equal to 1, the ellipse becomes a circle. So think about it and have a great day. All right, stopping recording. Excellent.